Monica is a partner with Bradley. She represents contractors, subcontractors, developers, engineers in utility scale renewable energy projects. She pays attention to risk mitigation, dispute avoidance through development, construction, operation, maintenance phases of the project. So she does it all. She probably even has worker boots that she goes out in the field in. She has a lot of experience in utility scale energy developer contractors, including drafting, negotiations of EPC agreements, subcontracts for utility scale projects around the world. And she's co-chair of the firm's Solar Energy Practice Group. Monica, tell us about yourself and Bradley.
Well, welcome everyone. Very happy to have everyone today for, I believe, David, this is our last 2021 Energy Technology Series, so we will move into 2022 after that. As David said, I am Monica Dozier. I'm a partner in Bradley's Charlotte office. My practice is focused on renewable energy, specifically representation of developers and contractors in all stages of renewable projects. I should amend my bio, David, and send it to you because I'm well into the DG space now, but that's the next frontier, so that's been a lot of fun. Bradley is a national law firm with 10 offices. We provide services to all areas of the energy industry, and we're a proud supporter of E4 Carolinas, which has been a fantastic organization and experience for me, be based in the Carolinas and get to know the industry here. On a personal note, I'm very excited to welcome Damien Beauchamp here to our E4 Energy Technology Series today. One of my first E4 memories was meeting David's colleague, or former colleague, I believe, Damien's former colleague, David Freed, learning about Net Power's technology and its potential. This was back in the day before Net Power's demonstration plant was opened and commissioned in LaPorte. So I am very much looking forward to hearing how 8 Rivers has grown and developed. Without further ado, I'd like to introduce Damien to everyone. Damien is the President and Chief Development Officer at 8 Rivers. Through his career, he has developed an expertise in CCUS-related project and technology development. Damien is also the co-founder and president of Coyote Clean Power and a member of the Net Power Board of Directors. In 2020, he was a co-author of the U.S. National Petroleum Council's comprehensive CCUS report, Meeting the Dual Challenge, a roadmap to at-scale deployment of CCUS, which was commissioned by the former U.S. Secretary of Energy, Rick Perry, and led by NPC. Previously, Damien started 2 companies for which he had been featured in Forbes and Fortune, while also having received several entrepreneurial awards along the way. Additionally, his work in the field of chemistry has been published and/or featured in Nature Chemistry, Journal of the American Chemical Society. I'm going to skip that one, Damien. Unfortunately, not very good with my pronunciation of that. And Chemical and Engineering News. Damien holds a master's degree in chemistry from The Ohio State University, during which time he was awarded the Future Leader in Chemistry Award from a division of the American Chemical Society, and then won the Clean Energy Business Plan Prize from the U.S. DOE. He has a bachelor's degree in chemistry that was earned at Kent State University. And as David mentioned, Damien is joining us from Abu Dhabi today. So without further ado, I will turn the floor over to Damien with our thanks.
Thank you so much, Monica, and thank you, David, for inviting us back as an organization to present on the developments we've made to date as a company, 8 Rivers, as well as giving a brief snapshot on what our partner company, Net Power, has done to date. I am joining from Abu Dhabi. I've been up since 5 a.m. This puts me at 19 hours. So please forgive me if I get lost for words at times. I might lose words that I'm looking for, but nonetheless, I think I'll be able to get through. So I'm here in Abu Dhabi attending ADIPEC, which is the Abu Dhabi International Conference for Energy. It's one of the largest energy conferences in the world. Easily there's over 100,000 people here this time, which I was quite surprised about. And we're here visiting multiple companies, and I'll touch on some of the companies that are here that are partnered with 8 Rivers. Having said that, I'm going to share my screen now and begin going through the the presentation that I've prepared for this. And I will just want to confirm that this is in presentation mode and everybody can see it okay. Wonderful. So 8 Rivers was founded in 2008 by Bill Brown and Miles Palmer, both MIT alumni from their undergrad. Bill then went on from MIT to get his law degree from Duke, and Miles went on to get his PhD in chemistry from the University of California at San Diego. Bill joined Sidley Austin Law Firm and then moved into various roles at Morgan Stanley, JP Morgan, and AIG on Wall Street. And Miles moved into SAIC in Washington, D.C., developing defense solutions. Late in their career, they got together and decided they wanted to develop a company that would make an impact in the world. For a number of years, 8 Rivers was looking to find its way and its niche and what market it would serve. And today, we are excited that we have very squarely found ourselves as the net zero solutions company. So the way I like to describe this, and what's worked quite well recently in presentations, which is a little more difficult in this setting, is I typically say a phrase, and then I ask people to say the first company that comes to mind. And so if I were to say electric car company, most of the answers I've gotten to date are Tesla. Search engine, most people answer Google. E-commerce, Amazon or Alibaba have been answers. And when I ask people who the net zero solutions company is of the future, I'm typically met with silence. Over the next few years, it is our mission at 8 Rivers to change that, such that when net zero solutions are spoke of, the first phrase that comes to people's mind is 8 Rivers. And I'll talk to you today about the path that we're on in meeting that challenge and what we've been seeing in the market to date. But before that, I think it's important to set the stage of how we got here. For many years, people used to ask 8 Rivers, why were we so focused on CO2-based solutions, and where was the market for CO2? And at the beginning of the pandemic, we were quite worried that our business was not going to do well. And to our surprise, there's been a full swing at net zero and achieving net zero through CCUS, or carbon capture, utilization, and sequestration. Of which I will mention, Net Power is the largest patent holder in the world of CO2 patents related to energy and chemicals. The other people in the class with us, the other top 4 in the top 5 are Siemens Energy, Mitsubishi, Air Products, and Air Liquide. 8 Rivers believes it has the advantage of being extremely nimble and having more innovative and economic solutions. Having said that, for a long time, people wondered why we were focusing on CO2. Ultimately, what we came to understand was that without physically touching CO2, there was absolutely no way that we were going to slow its entrance into the atmosphere. And we predicted that CO2 would continue to enter the atmosphere at staggering rates from 2008 onwards. And the reason we had that thought is because of this graph. Although people talk about reducing particular fossil or hydrocarbon resources, never in the history of the world have we ever used less of any hydrocarbon resource, including biomass. Biomass is the blue chunk in this energy stack, and never have we even used less of that. As economies develop, more fossil fuels are consumed, and the fossil fuel industry has developed over a century, and through that development has optimized its cost, such that fossil fuel sources are allowing people to come out of poverty because the cost of energy is decreasing. Now, we do believe that renewables are extremely important and play a central role. But we believe that there are plenty of organizations out there that have expertise in this space, and they have done a wonderful job in deploying the various renewable technologies that are available today. Having said that, never in history have we deployed more renewable technology than we have to date. Yet, we've never emitted more CO2 than we have to date. And that is because the renewable resources that are being deployed are simply filling gaps in a growing pie rather than taking more of a slice of another energy resource. Therefore, it is our thesis that you must physically touch the CO2, capture it, if you expect it to not enter the atmosphere. So that is the space that we plan to and have been focusing. And in the IPCC report, in the 1.5 degree scenario, there's a particular graph that was presented that showed without emissions avoided through fossil fuels, CCS, as well as BECCS, bioenergy with CCS, it was going to be difficult to near impossible to reach a 1.5 degree scenario. And since 2018, with Xero being one of the first companies to announce a net zero strategy, over 1,500 companies around the world have committed to some form of net zero at some point in time. And these commitments and these companies that have committed to these targets are what 8 Rivers see as our core clientele. Now, when we start to look at what has been done in the CO2 space, as of 2019, 35 million tons of CO2 had been captured from anthropogenic sources and sequestered or utilized. The IEA projects that by 2030, basically 8 years from now, we will be at 10 times that amount of CO2. And by 2040, we'll be in the billions of tons of CO2 globally. And this is the opportunity that we at 8 Rivers see. And so it's important to understand where these sources of CO2 are coming from so we understand what markets to enter first. And the oil and gas sector is an obvious one, and fertilizer is another. And fertilizer is an important point when it relates to fossil fuel, because so often we think that fossil fuels are typically in power plants or in internal combustion engines or in shipping or in aviation. But in fact, it's the natural gas that feeds fertilizer that has also lifted so many out of poverty by being able to grow crops in more strenuous conditions. And fertilizer, in fact, and its production is a significant source of CO2 emissions, and therefore of particular focus for 8 Rivers. From the IPCC report, we developed the Sankey diagram to talk about and to give a pictorial representation of all the sources of CO2, the methods of transport, and then the ultimate utilization or storage points. And what's interesting in 8 Rivers' approach is that we look to address everything from natural gas production to sequestration and CO2 utilization through the development of new products that utilize CO2. And when we look at utilization, the kind of utilization we're looking at is the kind of utilization whereby CO2 is put into aggregate material for cement, plastics, helped to produce, say, ethylene, the most produced organic compound on Earth. But ultimately, our objective is to put CO2 into products whereby it will never be re-emitted. The largest potential source for CO2 storage is obviously pure sequestration, and so that is of primary focus, and I'll touch on that more in a moment. It is interesting to understand that towards the end of 2020, there were 81 active investors in the CO2 utilization space, with over $177 billion under management across 11 countries. And they've invested a decent amount of money, but not nearly the amount that I think we will see over the next 30 years. The other opportunity we're seeing is that CO2 is a commodity. It will be priced by governments, by organizations and corporations, by markets and sovereign wealth funds. The World Bank and Morgan Stanley have agreed with our view and put out a CO2 kind of pricing equivalency metric across various countries. This, along with the companies that have committed to net zero ambitions, as well as the ideal sequestration geology, is what 8 Rivers has employed to determine its key markets for initial deployments, its deployments a decade from now and 2 decades from now. More on carbon pricing and forecasts from IHS and Bloomberg as well. Various countries have methods by which the abatement of CO2 emissions has been priced, either directly or indirectly. And I guess I will mention, obviously, with the recent infrastructure bill that has been passed, 45Q in the United States is looking to take a direct pay approach, whereby entities capturing their CO2 will get paid upfront from the government up to $85 per ton of CO2 sequestered. At that rate, some of our technologies become economic without even selling electricity or some of the byproducts. Strictly capturing the CO2 can produce a 5% IRR. And so we think there's a significant opportunity coming. So that's a bit of the foundation and thesis on why we're approaching the CO2 capture market and why we've built a company that's betting its future on this opportunity. Now I'll take you into a bit more about what 8 Rivers has been doing. So what are we offering our customers? Most fundamentally, we're providing solutions to clients to enable them to achieve net zero ambitions profitably. And that last part is quite important from our perspective. Without the economic return, it's hard to justify spending $500 million, $1 billion, or $2 billion, which is the scale of the projects we're looking at. We do this through 3 mechanisms. One is technology licensing. So we've developed a suite of intellectual property, process patents, whereby we've taken existing components and subsystems and configured them in a new way to achieve a new goal, and that is to produce what they were originally designed to produce while also inherently capturing CO2 economically. I will now jump to 3 because between 1 and 3 explains 2. 3, we're looking to develop projects as well as help clients develop financing strategies through our registered broker-dealer 8 Rivers Advisors. The projects that we develop will at times be owned either wholly or partly by 8 Rivers, and at other times we will develop these projects on behalf of clients as a service. In between our expertise in technology development and project development sits a services business. Across the world, over 1,500 companies have committed to net zero, and yet none of them have the expertise to understand how to achieve it, because that is not their core competency and that is not their business. And because 8 Rivers has focused on this for over a decade, we are in a unique position to provide rapid solutions that are sensible and practical, both economically and technologically. Some of the technological solutions we've developed to date are both Net Power and 8 Rivers Energy. The Net Power logo got knocked off my presentation here, but that sits under this first column. Net Power is the alum-FETVET cycle, which was invented by 8 Rivers that burns natural gas as its fuel source. That was licensed exclusively on a global basis to Net Power, the entity, which I'll get into a bit more in a moment. And I sit on the board of directors of Net Power, along with some representatives from McDermott, Occidental Petroleum, and Exelon Generation. 8 Rivers Energy is the alum-FETVET cycle when fueled by solid fuels, be it coal or biomass. Again, with near full carbon capture, we believe that this solution is going to be instrumental in regions like China, Australia, India, and even the Middle East, where Dubai recently finished or is getting close to finish 4 gigawatts of coal, new build capacity. So it's still being built around the world, and if somebody doesn't abate those emissions, we will continue to have issues. And so we're focusing on the hard things. 8RH2 borrows from our heat recuperation expertise, as well as our oxy-combustion expertise to produce blue hydrogen with inherent carbon capture. TART is a cryogenic sour gas processing technology, which will allow us to process the hydrogen sulfide content and CO2 content out of natural gas, preventing it from entering the atmosphere, while also producing a low-cost feedstock for the production of zero emissions power or zero emissions hydrogen. Zero degree DAC is a portfolio of direct air capture technologies we've been developing over the past 5 years. None of them have been released publicly and continue to be in development. And rather than taking a single technological solution approach, we believe that each situation is different for the various clients that we're talking to. And therefore, we need to have a bit more flexibility than just offering a single widget. And we've taken a more portfolio approach to our direct air capture solutions. Carbonate serves the cement industry through the production of zero emissions quicklime, and that quicklime also serves as a feedstock for some of our direct air capture technological solutions. Carbonate also acts as a post-combustion capture source for existing effluents coming from steel facilities or power plants. And the quicklime can actually be used to help treat coal ash. So you can convert certain coal ashes to cementitious material using quicklime. It's also already used for coal ash to dewater those ponds. And so we see that as an opportunity, kind of a dual approach to solving two problems at once. And one example that I'll touch on, which I think is particularly compelling, as an example, local to North Carolina, you have Duke Energy, who's committed a significant amount, $10 billion, to cleaning up coal ash. And they've been on that mission for a while, and they've done a tremendous job doing that, in our opinion. But without a significant CO2 capture budget, we see carbonate as being an opportunity whereby the budget associated with coal ash cleanup could also be used indirectly as a post-combustion carbon capture source for existing unabated power generation units. For these technologies, in July of 2020, we were awarded 8 of the 8 DOE grants. One of them isn't on here, that we applied for. These technologies, or these grants, cover nearly all of the technologies that I just presented. So they've already gotten their third-party merit from review and approval and funding from the DOE. Some of these take the alum FETVET cycle to the next generation through looking at optimized energy storage. So now I want to take a moment to kind of touch on the history of Net Power and how we got to where we're at and where we're going. So in 2010, Rodney Allen, Bill Brown, and Miles Palmer came together and invented the alum FETVET cycle. At the time, it was called the alum cycle. The other early employee, Jeremy FETVET, has had his name added recently, as he kind of brought the solution into technical practicality. He solved a lot of the real world problems for deploying the technology in the field. The advantages of the Net Power system is that it produces near zero emissions power at lower power costs than traditional carbon capture. It complements renewables through a storage mechanism, the molecular storage mechanism of oxygen, generates multiple revenue streams through the sale of industrial gases, and it can be deployed anywhere. It does not need water, nor is it affected by elevation the way that CCGTs are. Soon after the invention of the Allen FETVET cycle, Net Power, the company, was formed by 8 Rivers, who is the corporate founder. Thereafter, Shaw Group invested $50 million. Shaw then was purchased by CB&I, and CB&I was purchased by McDermott, hence McDermott being the current shareholder. Exelon Generation then came in and invested $100 million. And the demonstration facility in LaPorte went under construction in March of 2016. And it was 2 days after I joined 8 Rivers that the team had just went down to LaPorte to break ground. So I got to kind of see the construction and commissioning of that facility. Upon commissioning in late 2017, early 2018, when first fire occurred, Occidental Petroleum then joined the consortia, investing an undisclosed amount and becoming a critical partner. The wonderful nature of the partnership around Net Power is that companies like Occidental Petroleum have particular expertise in transport and utilization of CO2. Here in Abu Dhabi, they've partnered very closely with ADNOC, the Abu Dhabi National Oil Company, and have worked with that group for quite some time. And they also have international footprint in Oman as well, and other countries, Venezuela and others. Exelon has an expertise in operating power plants, so obviously a critical component. McDermott knows how to build and construct large infrastructure. And 8 Rivers understands the financing mechanisms, the sales and marketing strategies, as well as the continued innovation of the technology. So this is a little bit about how the cycle works. I know that some people on the call already know. For those who don't, instead of burning natural gas in ambient air, we burn natural gas in an environment of pure oxygen with CO2. So we produce oxygen through an air separation unit, a cryogenic means of separating the components of air. Oxygen and nitrogen are combusted with a stream of CO2. That CO2 is then heated through combustion, passes through a turbine, then a heat exchanger where the heat is transferred to a recycling stream of CO2. Because the heat has been transferred, the CO2 water mixture cools down to ambient temperature and the water comes out as a liquid, and the CO2 continues to move through the cycle. Because supercritical CO2 has a high heat capacity, and because you can pump supercritical CO2 rather than compress it, you're able to minimize the parasitic load required for repressurizing your recirculating stream. Pumping takes less energy than compressing, and so that is one of the secrets of the cycle, is to use pumping of the CO2 rather than compression. So we try to maximize the pumping. That CO2 then goes back through the heat exchanger, being reheated, comes back into the front end of the combustor, and continues again. So the advantages are that the CO2 is kept in the system, it's inherently captured at high pressure and purity, and for every stoichiometric amount of additional CO2 that is produced from combustion, the system is able to output high pressure, high purity CO2. In this picture down at the bottom, you'll see Rodney Allen. He is the inventor of the core Allen FETVET cycle. He's based out of the UK. And I'll discuss a little later how this story is kind of coming full circle on Net Power in a bit, not only here at the E4 Carolinas presentation, but also from a technological deployment perspective as well. The Net Power facility you can see there is down in LaPorte, Texas. We're right next to an Air Liquide SMR there in the background. So we're a substantial size. That SMR in the background is the largest in the Houston area. So this facility is substantial in size and has been operating for most of 2021 after being offline for a bit. And so, as I touched on previously, 8 Rivers has licensed exclusively globally, not irrevocably. You know, all those. I'm sure Monica can appreciate all those terms that I'm running through. To net power for the natural gas-fired Allen Fetvet cycle, and the core Allen Fetvet cycle, when used with solid fuels, is retained at the 8 Rivers level, and we have full ownership of that particular technology. And there are many companies around the world that are interested in this. When used with biomass, we create negative emissions power generation. Now, given that I'm in Abu Dhabi, I thought it would be only fitting to share that in 2018, this little North Carolina firm was recognized in Abu Dhabi at the ADIPEC Awards. In 2018, we received the Breakthrough Technological Project of the Year award, and then were featured in the 2019 award series. I was pleased to see that another organization that has a significant North Carolina footprint, Siemens Energy, has won tonight at the Emirati Palace the ADIPEC Award for Low Carbon Company of the Year. And so very, very pleased to see that for them tonight. All right. So that's a little bit about net power. From that, we've developed a zero emissions hydrogen production technology, whereby we take natural gas and pure oxygen, and we do a thing called partial oxidation with autothermal and gas heated reforming. So we're borrowing our heat recuperation expertise that I just spoke about with that heat exchanger. We're basically just backing off the oxygen a bit. So we're not doing complete combustion. We're producing a syngas, and then we're fully oxidizing the carbon monoxide produced in that syngas through water gas shift, producing some additional hydrogen, and then inherently capturing the CO2 through both pressure swing absorption for H2 purity, as well as a low temperature CO2 separation process after we use a dual phase PSA. We're using kind of a Johnson-Matthey core ATR technology for this, and then building into it some of our expertise to achieve 99% carbon capture for hydrogen production. Now, for this process, as well as the Allen Fetvet cycle, an air separation unit is required for the oxygen. The air separation unit also produces significant amounts of nitrogen. If you combine nitrogen through a Fischer-Tropsch process with hydrogen, you'll produce ammonia. And so if we go back to that first slide where I said we're very focused on the core industries where emissions are happening today, that this kind of helps bring that full circle, whereby we're starting to look at solutions where we can integrate our hydrogen facility with Allen Fetvet cycle-based technology to get full carbon capture, and using just traditional ammonia synthesis processes to produce ammonia. We can see efficiency benefits through generation and transfer of waste heat from the hydrogen facility to the Allen Fetvet cycle facility, as well as electricity being used from the Allen Fetvet cycle facility to run the auxiliary portions of the hydrogen plant and the ammonia synthesis plant, as well as the air separation unit. I will say that the region that I'm in today, this construct is particularly attractive. I can't name the companies that we're engaged with, but there have been several announcements about ammonia being shipped to Japan as a zero carbon offset fuel, or a fuel switching method for abating emissions from existing coal burning assets in Japan. The reason that ammonia is good to replace certain types of coal is because its MMBTU value, its heating value, its energy value is similar to that of coal. Now, ammonia can be more expensive as a fuel, and that's why key markets to look at are those that already have high costs of fuel imports. Places like Singapore and Japan are good first emerging markets to sell ammonia as a fuel source because their costs of energy, LNG, and other resources that are imported are already relatively high. Therefore, the economic swappability becomes achievable. Additionally, we've started to look at the flaring issues in this region in the Middle East. So typically, multiple BCF of gas, a billion cubic feet of gas, will be flared at the beginning of a well's life in this region, and tremendous amounts of CO2 and methane escape to the atmosphere. We've developed a relatively modular approach to cryogenically monetizing, capturing, and sequestering the waste products, as well as producing the valuable streams from that process. Additionally, we've put in financing mechanisms into the licensing of this technology such that the fuel produced and sold to a consumer would need to come with a CO2 capture certificate or abatement certificate, whereby that purchaser would then get a rebate were they to show that they captured certain amount of carbon when purchasing this fuel. And we're working on developing a private party mechanism to incentivize carbon capture. A bit different than a 45Q, but there are certainly mechanisms that one can develop through a technology licensing strategy. This technology, we've actually partnered with Toyo Engineering out of Japan. They've developed a full process design package, as well as all the details we need to be able to deploy it with customers who we're talking with. And they did this in kind because of the promise they saw in the technology and their desire to become our engineering partner as we deploy this solution commercially through various regions of the world. So that's a bit on our technology portfolio. And now the couple things I didn't go through in that technology portfolio are, again, the carbonate solution, the direct air capture solution, and a process whereby we convert ethane to ethylene. Ethylene is the most produced organic compound on Earth, and we use CO2 instead of steam. Typically, you're steam cracking to produce ethylene. And we've developed a mechanism to produce ethylene using CO2 as a soft oxidant, whereby you get ethylene and carbon monoxide and hydrogen as your products, and some water. And we believe that that will be a very promising solution in the years to come. We've been awarded a US patent and are working on international patents for that particular technology. Particularly proud of that, as I was the inventor for that. And we've got a long life for that technology, and so that's to come. So now I want to get into a bit of our net zero project portfolio. So another thing we realized was developing and inventing technology wasn't enough. Unfortunately, there wasn't enough action by entities in the marketplace, and therefore we're taking a leadership position to take the first steps in developing projects and then bringing partners into those projects through selling equity in our project vehicles. Now, between the technology development and the project development, one firm did see what we were doing, and that firm was JX Nippon out of Japan. And last Tuesday, we announced our collaboration agreement with JX. It is substantial, it's global, and they are very committed to working with us. For those that don't know, JX Nippon was one of the first investors in Petronova, the large-scale carbon capture project in Houston with NRG. So JX has a long history of CO2 capture, management, injection, and we're looking forward to working with JX, and we're honored that they wanted to work so closely with us. Part of the reason they saw promise was because of the footprint that Eight Rivers has. And a lot of this hasn't been made too public because we believe more in action. And so we're working on the action part rather than announcements. Though we have started to ratchet up the announcements as those announcements follow our action. We have 4 projects that are in development today, and I'm going to touch on all of these. And so the different colored dots represent the different technologies that we've developed in the regions in the world where we've found either deep due diligence that is ongoing, or we've been paid for engineering services in these regions by clients within these regions for those particular technologies. Or we're actively developing projects with counterparties. The 4 projects that are indicated by the numerals within the circles, the gold circles, are marquee projects that have been under development for about 2 years at this point. The first that I'll touch on is Broadwing. So that's in Decatur, Illinois. The next is Coyote, which is in the southern part of Colorado with the Southern Ute Indian tribe. The third is Whitetail in Teesside, and I will touch on each one of these projects in more detail. And the other is Project Poakai, which has been a bit stalled as New Zealand has shut its borders for an extended period of time due to COVID. And so that project hasn't progressed as quickly as the other 3, but nonetheless is still an interesting opportunity. And in fact, Australia has now gotten on board with the concept as well. And we've done quite a bit of work there. We've done work in Japan, in Europe, in the Middle East, in Alberta and Saskatchewan, and throughout the United States to date. So first, I want to touch on the Whitetail Clean Energy Project. The co-investor on that project is Semcorp. So they are a large kind of tenant of industrial sites, and that industrial site you can see there in that photograph. So that's along the Tees River at Teesside in the UK. Of the 5 CCUS hubs that were in competition in the UK, 2 were down selected. One was the East Coast cluster, for which Whitetail Energy is a member, and HyNet, which is on the other side of the UK. We've been featured in the UK's CCUS growth strategy reports, and this is a core project for them, and was also featured at COP in Glasgow last week and the week before. You can see the 3D rendering of the actual plant, which we've been engineering and developing. And we're quite excited about this. We have support all the way to His Royal Highness Prince Charles, who Bill, our co-founder and executive chairman, has developed a relationship through Prince Charles' Sustainable Markets Initiative. And I'll touch on a little more on that in a bit. So we think that this project is very promising. There's a contract for differences on the power that guarantees a power price, which we think helps alleviate risk. And what's interesting about this is really the kind of full circle project for us, because the first funding into Net Power, in fact, came from the UK government through a grant for $10 million in around 2010, 2011. Additionally, Rodney Allen is obviously from the UK, former chief technologist at Air Products. And here, this commercial scale project is now coming back to the UK, proving that their initial investment was worthwhile. The other facility that we're developing is in Decatur, Illinois. Again, critical infrastructure in place. The 2 Class 6 wells that have been permitted, Class 6 wells are the designation for CO2 sequestration wells in the United States. There are only 2 that have ever been permitted. Both of them are at this site. So what better place to develop a large-scale power production and steam production carbon capture project than where you already have access to sequestration. And so we've partnered with ADM and Warwick Capital Partners to deploy this solution, which will be a dual zero emissions electricity and steam solution. Some of the power will be used in ADM's industrial facility, and the steam will as well. The other project we're developing is in partnership with the Southern Ute Indian Tribe, the Southern Ute Growth Fund, and their subsidiary Aka Energy. The Southern Ute Growth Fund has substantial natural gas production on its reservation, as well as midstream processing. They own offshore platforms and have significant operations in Texas. They are quite advanced and experienced in the energy business, and their PE fund through the Southern Ute Growth Fund is one of the largest in the United States that nobody knows about. And because they see the importance in taking care of Mother Earth, they have seen an opportunity to reduce their impact on the environment by utilizing their gas resources in a zero emissions facility to produce stable baseload power. This project is very near the Four Corners region, where the San Juan generating station fired by coal, as well as the Four Corners generating station, and multiple of Excel's coal burning assets are being retired. Around 4 gigawatts is going to be retired in this region by 2030. Substantial stable power will need to be deployed in order to support the renewable deployment that is also being targeted. Regions like Arizona are already seeing power prices above $200 a megawatt hour because of the overcommitment on solar and the undercommitment on stable zero emissions baseload power. These are facts we've seen in California, in Germany, and we continue to see. Without stable zero emissions power sources, we will continue to increase the socioeconomic disparities of the world. And this is one project where we see that being vital. We see a big socioeconomic component to this project, and also being able to bring innovative technology to tribal nations. In addition to the projects, we've joined multiple organizations and made commitments. So we've joined the group through the groups that you see to the left in the Sustainable Markets Initiative by pledging our commitments to deploying and producing certain volumes of hydrogen by certain dates. All of these global organizations have committed as well, and we were honored to be a part of this prestigious global energy group. Additionally, as I mentioned earlier, the UK government has featured us in their net zero strategy, specifically naming the Whitetail project in that multi-page document. Additionally, last week we signed an agreement with Monetizing Gas Africa, a company that produces natural gas in Africa and LNG, in order to assist them and provide them with net zero emissions solutions. Further, there's a group out of the UK called Navigator Terminals that produces and develops, owns, and operates large bunkering resources for things like ammonia, hydrogen, and CO2. And we're working towards not only shipping terminals, but the shipping of the CO2, hydrogen, and ammonia around the world. So that's all I have for you all today. I hope that was enough. We've been very busy, and we are excited about announcements that we believe will be forthcoming over and through the end of this quarter and into the first quarter of 2022.
Damien, thank you. And I don't think your closing comment of "that's all I have" is at all appropriate here. That was a lot, my friend. So we have a couple of questions in chat. I'm going to pose those, and then I've got a couple of questions of my own, as you can imagine. First of all, let me give a shout out to Siemens Energy. You mention them as a winner over in Abu Dhabi. We have Selena Schaefer, Siemens Energy Director, and Tanya Sessions, a manager, online with us, and they're both involved with power generation activity. So I'm sure they're taking notes and as to what Eight Rivers is up to. And I know that they probably did just a silent victory lap with regard to your announcement.
Yeah, Torben Fors, the head of industrial solutions at Siemens Energy, is over here as well. So, yeah, it's exciting stuff.
Selena, Tanya, you want to unmute? Have any comments with regard to that?
That's exciting. Thanks for letting us know.
Thank you, Selena. All right, on to some questions. First of all, a simple question. Are the plant capacities the same for solid fuel as for natural gas?
Relatively. The natural gas solution that Net Power is licensing around the world is going to sit in around 280 to 300 megawatt electric, depending on the configuration. And what I mean there is the Whitetail project, for example, is going to produce around 300 megawatts electric, as we're anticipating, because there's already an oxygen supply source in place. So we don't have the parasitic load of the air separation unit, which typically would take that delta. When you do have an air separation unit, you'll achieve around 280 megawatt electric. For the coal solution, we will achieve anywhere from 300 to 350 megawatt electric.
Damien, a follow-up question from me. With regard to biomass or cellulosic material, are you combusting it outright, or do you have a digestion process that's a preliminary that's producing a gas for you?
Yeah, so what we do as a first step in the solid fuel system is we produce a syngas, and we have a syngas combustor that then combusts the syngas. In fact, the DOE awarded us a $15 million grant program to develop that syngas combustor, having proven the natural gas combustor system at LaPorte. And so that work's underway. That facility in LaPorte is currently operating under natural gas conditions, but Net Power is a co-recipient of that grant, and we're looking to utilize that facility to develop that syngas combustor.
And another follow-up question from me: if you're producing syngas on the front end, I'm assuming that there's a solid waste component on the front end, and if so, have you found a creative way to deal with that? Because I know, for example, when you go eastern North Carolina, you've got the hog waste facilities where they're producing synthetic natural or renewable natural gas, and they've got a waste issue there. So I'm curious as to whether you've had to deal with waste issues.
Yeah, certainly. Just like any other coal facility, our approach on the coal side of things is to produce a slagged product. We think that a non-leachable slag is the best approach there. And ultimately, we look to, at the beginning of those types of projects, which currently we don't have any announced facilities for the solid fuel system. But when we do, we look at the very beginning of those projects to be developing solutions to remediate or repurpose that coal ash to the extent possible.
Thank you. Question from the chat: are the plants designed modular and the primary component suppliers established, or is each of these plants custom designed with primary module custom ordered based on unique project characteristics?
Wonderful question. So on the Net Power system, Net Power, the company will manage a standardized approach to the commercial facility deployment. They will manage a approved vendor and supplier list. Various OEMs will be pre-approved and certified such that the facility will achieve the stated output depending on the circumstance of the project. We don't believe that every solution will be a custom build. In fact, modularization of the various subsystems is key in the strategy to date in designing those commercial facilities, such that we have skid-mounted subsystems that come together in the field, limiting the amount of field labor and thus limiting cost through erection of the facility. For some of the other technologies like TART, the cryogenic gas processing system to abate upstream emissions, that is very much modular. Our approach there is such that we would be able to move those modular units to various wellhead locations to prevent flaring and venting, and while also being able to monetize that. And we've designed that solution to be quite compact relative to what's available in the market today for similar solutions. There are some iterations. The unique feature about the Allen-Fetvet cycle is that it can operate on an air-cooled basis. Because a natural gas combined cycle uses steam for its secondary turbine to produce additional power, you need water. And you typically need a certain amount for cooling. And if you're doing amine post-combustion capture, there's also a water component associated there. Because the Allen-Fetvet cycle, the net power solution, or the Eight Rivers energy solution, neither use any adsorbents nor any water in the production of power. Those facilities can be net water neutral. And what I mean by that is they will neither consume water nor produce wastewater. So the water that is produced from the facility can be vented through the generation of steam. And this is actually an approach that we're taking in the Coyote Clean Power Project in Colorado, because we have no water available to us, and so we're going through an air-cooled method. On the Eight Rivers hydrogen solution, with respect to modularity, that is the goal. Ultimately, it's basically a large SMR, call it but partial oxidation gas heated reformer. And when we look at the more integrated solutions, like let's say our hydrogen solution going to ammonia, those can be more custom build. When you start to look at the multi-billions of dollars, you're certainly going to take into account environmental conditions and various desired outputs to maximize your economics through the design of the facility. But the fundamental kind of core principles will remain the same throughout the facility. Having said that, we're hoping to announce a pre-feed later next year around our 8RH2 technology, but at this time we're not able to say more. And through that, we will have a standard design package for that technology, as we do for TART and the other technology.
Damien, your answer may vary by project, but typically, how much of the captured CO2 is utilized either commercially or reused in the process? How much gets sequestered?
Yeah, so with the Allen-Fetvet cycle, we will achieve 98% capture and sequestration. So 98% can make it to the sequestration site. And that's one of the advantages, is the very high capture rate. On the 8RH2 technology, the goal that we had put in place was to produce a blue hydrogen with 99% carbon capture. As it's currently designed, that system achieves that goal. as we've designed it. We still have yet to deploy the 8 or H2 technology, but that's currently what we're seeing, and we have had third-party validation on our numbers there. And for the tart solution, CO2 is injected into the sour gas as the scrubbing agent, and then any additional CO2 that comes with the sour gas that's in place in the ground will also be pulled out. And the amount of CO2 that's produced from that facility is really just dependent on the amount of CO2 that's inherently in the natural gas. And what's interesting there is a lot of people don't realize that in natural gas processing today, when there is CO2 content, a lot of that just gets vented because there actually is no regulatory framework limiting the amount of CO2 that can be vented into the atmosphere. And so that is a situationally dependent piece. So if you looked at the integrated ammonia production facility, we're well over 1 million tons per annum. On a natural gas net power facility, that will sequester around 820 to 860,000 tons per annum of CO2. For the 8 Rivers Energy solution at 300 to 350 megawatt electric, anywhere from 1 to 1.2 million tons of CO2 will be captured on an annual basis. And so that, I think, gives you a sense of the volumes of CO2 that these facilities will capture and ultimately sequester or otherwise utilize.
Damien, are you seeing 8 Rivers project activity being driven more by market economics or regulation? And if it's a blend, where in the world do you see these dominating?
So right now, over the past year, and ultimately the JX announcement is part of a culmination of our effort. We have been doing what we're calling a demand-driven raise, where some say, they take more of an aspirational approach. If we build it, they will come. For 8 Rivers, what we've seen is we have built it. They are here. And we need to rapidly expand our resources to be able to meet the market demand that we're seeing. I would say all of our active outreach has often been met with a very positive response, and a tremendous amount of the work we've done has been as a result of organic interest from the market. And that's been ramping substantially, accelerating substantially lately. Key markets, the United States is the largest emitter in the world. We've put more CO2 into the atmosphere than anybody else, and so clearly our government and our population is kind of taking responsibility for that and creating one of the strongest CO2 incentives and markets in the world through 45Q and 45X, which is a hydrogen credit that's similar to 45Q that's in that bill. And so that's one of the key locations. This is one of the key locations we look at. The UK is also very forward focused on CO2 capture, as is Australia. I will say a very close second to that is now Europe, who is taking a pure green hydrogen approach and renewables only approach, but now we're seeing a lot of European coastal entities starting to consider the sequestration of CO2 offshore, and we've been engaged directly with that. Most recently, you've seen commitments coming from places like the UAE and Saudi Arabia just a few weeks ago on their commitments to net zero. And so we think that's very exciting. But first markets for us are certainly going to be places like the United States, where we have over 5,700 miles of CO2 pipeline already. Alberta, which has the Alberta Carbon Trunk Line, which can transport CO2, and regions like the UK, where you have government support to develop significant offshore CO2 sequestration assets.
Damien, any thought with regard to nuclear reactor co-location, using it as a source of heat or some other function?
Yeah, so that's a wonderful point. We in fact have been approached because of our understanding of supercritical CO2 to look at those types of integrations. We're very interested in them, and it's a very practical and insightful question, and we're active in that space right now, just not publicly.
How about examination of integrated energy system co-location, where you have producers and users tightly packed together? Are you exploring any opportunities like that?
Um, I would say, a good example, a tangible example of one that we're working on is kind of the Whitetail project. So what's interesting about that is SemCorp owns an entire kind of industrial complex, and they have tenants. And to those tenants, they provide the utilities. So you can come in and kind of plug in your large industrial complex, and you'll have access to things like oxygen and power and water and all the various things that one might need. And Sabic operates on that site, and there's the opportunity to provide the zero emissions power that will be generated to not only Sabic but to all the tenants of the SemCorp site. So they will have the advantage in the marketplace of being able to offer a first of a kind zero emissions power solution to all of its tenants at this location. And so that's where we see kind of a direct co-location with potential consumers and while being a producer in this instance. And I think that our approach on direct air capture is similar, where we're looking to repurpose existing assets to achieve the direct air capture component. But costs, we believe the costs of our technologies are quite low compared to conventional technologies, but it's still a very expensive way to capture CO2. And we're focused on driving that cost down as rapidly as possible through system simplification and utilizing existing infrastructure rather than new build.
Damien, I have one more closeout question for you, but before I do, I know that you're acquainted with John Downey, the Charlotte Business Journal. John has followed 8 Rivers and its various activities since the beginning. John, I'm going to give you a heads up. If after I ask my last question, if you have any, if you'd unmute, I'm sure Damien would be pleased to answer your questions as well. So, Damien, my last question deals with the introduction of hydrogen. To the extent that it can be introduced into interstate natural gas pipelines and distribution lines. Do you anticipate that the blending of hydrogen with natural gas will affect at all the net power technology design?
I don't think so. So the Allen-Fefet cycle is well suited to be able to accept the kind of volumes of blended hydrogen that you're mentioning. So we've seen companies like Williams recently got a grant awarded from the Wyoming Energy Authority. Williams operates a very large natural gas pipeline network throughout the United States. And it's public that they received this grant from the Wyoming Energy Authority to begin studying their pipeline system and inventorying, if you will, the various materials throughout their system. So as you can imagine, that system was built over decades. And so different materials were used in different locations, and you have to figure all that out. And so I think what will come out of that study, the portions that I would imagine would be released publicly at some point, will give us an understanding for the amount of hydrogen that can be blended. We know, in the UK, the limits kind of are reaching around, I've heard as high as 20%. In the US system, I see, 1 to 8% being a very promising number and perhaps achievable. And when you take the total volume of pipeline and you put in that much zero emissions hydrogen, you do a significant reduction in CO2 emissions off the start. And so what ultimately drives it is looking exactly as you were mentioning at the downstream users, though, right? You have to look at the residential natural gas burners, the industrial gas burners, the power plants, and understand that there will be no effect to those various assets. And for the net power system, a small amount of hydrogen just will produce a bit more water, which just means that there will be less CO2 to export. The recirculating stream will remain the same, but the export is a direct function of the stoichiometry of the gas coming in. And so for that incremental additional amount of CO2 we produce from combustion, you would just have to take out that CO2. So we would just take out less CO2 and a little more water in those circumstances. And in fact, because those systems use what we call synthetic air, a mixture of CO2, oxygen, and natural gas for combustion, we can actually control the Wabi index of the fuel by simply backing off the amount of CO2 we blend in the combustor, which makes it relatively agnostic to the fuel coming into the front end, which is the MMBTU, the heating value of the fuel coming into the front end. I.e., if your heating value is lower, you simply decrease the amount of CO2 you're inputting. If your heating value is higher, you can increase the amount of CO2 you add. Yeah.
John Downey, are you still with us? And do you have any final questions for Damien? All right, John's going to pass. Damien, we just touched on hydrogen.
Yeah.
If you could just take a minute and, to the extent you can, tell us what Eight Rivers' plans are with regard to hydrogen.
Yeah, so I mentioned that we're looking at some projects. We're looking at opportunities in the U.S. We hope to make some announcements coming in 2022. We're excited about it. We think we've done some work in Australia, and we certainly have interest in this system. We will have more to announce on this, but certainly don't want to get out in front of my skis before everything's in place. So I will say I do expect some announcements around kind of detailed pre-feed and feed work coming in the future, and we're working on those things now. I will say, if I could just add, I thought one compelling question that was asked was about North Carolina and South Carolina CO2 sequestration and projects in the Southeast. If I had to pick the Southeast as a whole and say, where are we going to, where would be ideal locations? Because there's a CO2 sink already in Alabama, that's a very promising location because you've already got the proven reservoir, if you will, or geology and the infrastructure in place for sequestration. From a geologic perspective, North Carolina and South Carolina aren't necessarily ideal for sequestration of CO2. Some of the approaches that we've thought about, which we think are compelling, it would be to take existing, again, we love to engage on the stuff that so many people like to stay away from. But we really like and think there's a big opportunity in the coal ash piece, whereby if you added quicklime to coal ash, you created a hydrated quicklime and then injected CO2 into that slurry, you could cure a mineral-based product that would be solid and non-leachable. You don't even have to use it for building materials. You could simply solidify in place while simultaneously sequestering CO2. We know this is possible because of technologies like carbon cure that are injecting CO2 into cement. And we think a simplistic approach could be taken to achieve this. And one could look at even putting kind of the rubber mats that they put over the hog farms to the hog waste to collect the renewable gas over these coal ash ponds as you're injecting your CO2, so none of it escapes, and you could just continually recycle. We think that's an opportunity. We've certainly been looking at it in the South with, some of the larger coal burning assets and things like this. But we think there's an opportunity for an environmental leadership there. And many of the large utilities have already taken a tremendous leadership approach through their commitment in dollar amounts to actively working solutions there. And we think there's more opportunity there, but also commend the companies like Duke Energy who have taken such a kind of forefront and leadership approach and have really just stepped up, I think, in a very commendable way, instead of backing away. So we're very pleased with that. Yeah.
So Damien, John Downey did have a question. He's not able to unmute and pose it himself, but he put it in chat. He said he's interested with regard to the JX Nippon agreement. Is it essentially to use 8 Rivers technology for carbon capture and storage? Or does it include, oops, it just got away from me here. Does it include any investment from JX Nippon?
Yep. So it includes the deployment of our technology globally, and looking at various projects directly with JX, and there was an unannounced associated investment. Yes. And
Damien, knowing that you're headed beyond 21 hours awake, having made the trip across the Atlantic to Abu Dhabi, we're going to thank you. And again, I mentioned at the onset that this is a significant program for us. It brings us full circle with truly unqualified success of a Carolinas-based organization in the global energy sector. We thank you, and we appreciate all that you and your colleagues at 8 Rivers do